Dear students, welcome to Sia's digital classes. Today, let us learn the concept of single sample mean when in problem. How we'll do the procedure and all. Let us learn that. So, single sample mean if there is a problem, check it out. So, an ambulance service claims that it takes on an average of 8.9 minutes. So, average what we got. So, it is a mean, one of the mean we got. And next, let us check it out based on the question. Let us go for the single mean formula or not. Let us check first. So, some average value have got. So, some mean have got. Maybe population, maybe sample. So mean I have got here. For an ambulance to reach its destination in emergency calls. So here is a data about some ambulance services. So on an average how it reaches its destination they have given here. Next, to check on this claim, the agency which licenses ambulance service has timed them on 50 emergency calls. So sample size they have given like a 50 emergency calls. If you get in that emergency calls how on an average they are reaching, they are given information for us. So n we got now, mean value we got now. Then getting a mean of 9.3 minutes with a standard deviation of 1.6 minutes. What can they conclude at? Alpha is equal to 0.05%. So yellow is they have given for us, and they want to check it out based on the 50 emergency calls how the average impacts the data. They are given in the question. Now let us check it out. Null and alternate hypothesis in the given information, how it goes on. So null hypothesis H naught mu is equal to 9.3, because check it out here, getting mean of 9.3 minutes they have given here, so that becomes your population mean. So null hypothesis always will represent through population mean, right? So mu is equal to 9.3, that is ambulance service takes 8.9 minutes to reach its destination. So we frame the null hypothesis based on the data. Next, similarly we have to frame alternate hypothesis also. H1, so here equal to we considered, so H1 alternate hypothesis should be not equal to, so H1 mu not equal to 9.3 means ambulance services does not take 8.9 minutes to reach its destination. So that is a statement for alternative we have considered. Now let us check it out. Test statics, what is the given information, and then let us go for the particular test statics formula which we are going to implement here. So sample size n is equal to 50, 50 calls they have given it, so that becomes a sample size for us, n is equal to 50. Then x bar mean value, sample mean will call, sample mean is 8.9. In the beginning they have given, right? So 8.9 becomes a sample mean for us. Then mu, next to whatever the average they have given, that becomes a mu population mean, that is 9.3. Then under population mean in continuation we got a standard deviation, so that becomes a sigma, that is population standard deviation. So sigma is population standard deviation. You need to identify these things which are population values, which are sample values. Based on that only we can go for the formula or we can go for the particular test. So this becomes a population standard deviation. Mu is population mean, right? Next, x bar is sample mean, right? So n is sample size, that is understood. Always n, small n is sample size. So these are the data we need to identify through the question. So let us check one more time the question. So an ambulance service claims that it takes on an average 8.9 minutes to reach its destination in emergency calls they have given. So average is the clue that it goes to sample mean. So on an average we got, so x bar we got as 8.9. Then here n at 50 emergency calls, that becomes a n for us. Then getting a mean of 9.3 minutes and its standard deviation is 1.6. So this becomes your mu, this becomes your sigma. So this all information we got. So obviously these all information will fit in a single mean formula. From large samples, n is 50 we got, so that becomes a large sample. So large sample, this all data fits in a single mean formula. So let us go for the single mean formula and let us obtain the answers to that. So what is the formula for that? Remember, so z is equal to, formula is z is equal to x bar minus mu by sigma by root n is the formula. So it comes out of normal, standard normal distribution. So that also we represent here, n is equal to standard normal with mean 0 and variance 1. So this is the formula we have to utilize. We have all the information here. Simply substitute and get the answer. So I am substituting x bar, that is 8.9 here, 8.9 minus mu is 9.3 divided by 1.6, that is sigma, root over 50, that is sample size n. So I have substituted all the values, take the calculator, calculate it and get the answer. Upside, after doing subtractions, I have got as minus 0.5. Downside, by dividing and root over values, I have got as 0.22. Then finally we have divided the value, we got the answer z. Z calculated, we'll call this one. Z calculated is minus 1.767. I have got here. So this is your calculated value z. Under that write down CAL, that is your z calculated value. Now to compare the data and to get a decision, we have to take critical value also. So how the critical value will be and how the decisions we can make, let us learn now. So critical value decision we have to take here. So critical value depends on level of significance. Yes, level of significance they have mentioned in the question, that is 5%, that is 0.05 they have given. So if at all they don't mention any level of significance in large sample test, consider as 5% here. Here anyhow they mentioned as 5%, so go for it. So and tailed test also depends on tailed test also will decide. So tailed test, in the previous concepts you have learned, check it out. And from second unit, what are the tailed tests? So whenever not equal to symbol you will get in alternate hypothesis. Let us have glance on alternate. So whenever not equal to symbol you will get in alternate hypothesis, that is that symbolizes the test statistics, tailed test for us. So not equal to type is two tailed test. Now based on two tailed test and the level of significance, we get the critical value here, table value. So here 5% LOS and two-tailed test will get, so the critical value becomes 1.96. So large sample test we have to decide the critical values based on LOS as well as tail test. So we got here based on two-tailed and at 5% LOS I have got as 1.96. Now I have a table value with me and a calculated value also. Let us compare and let us get the answers. So comparison is mod z calculated is less than mod critical. Whenever mod values means whenever negative values you are getting, make it as positive by using the mod symbol. And always if a calculated value is less than the table value, we'll call as critical value also. So if calculated value is less than critical value, then accept H naught, that is null hypothesis. Whatever we have supposed data, we need to accept, that becomes a decision for us. Otherwise, if it is not less than, if it is greater than, you got reject that hypothesis, null hypothesis you have to reject. So that is a conclusion for every large sample test. So let us check it out. Here in our problem, we got less than or not. So our calculated value I have got as minus 1.767. So within mod I wrote so that it becomes a positive. So check it out in the next line. Positive value I wrote. So 1.767 is less than 1.96. Yes, obviously 1.7 is less than 1.96. So our null hypothesis is accepted because less than symbol we got. So accept H naught. Here we are accepting H naught. Now what we wrote under null hypothesis, that is ambulance service takes on an average of 8.9 minutes to reach its destination. So that becomes your final conclusion. Yes, ambulance services takes an average of 8.9 minutes to reach its destination. It becomes a decision for us. That is a conclusion. So this is the problem of of single sample mean. So under large samples, so you have to identify the data based on the question. You have to identify based on the information. You have to identify which test you have to handle, and based on that particular, go for the taking out the test particular test statistics, and decisions you have to take based on the conclusions based on the calculated value and table value. So this is the concept of single mean. Hope you have understood this problem. See you all in the next session. Thank you.